In this video, I want to take a look at a first order system, and a first order system is shown in on the slide here, right? So the transfer function is given by k over s plus a. We have an input here and we have an output. And I want to look at the response of this first order system to a step input. So to do that, I need to calculate what my output is going to be for this system. So I can write ys equal to k over s plus a divided by 1 plus k over s plus a times rs. Okay, I'll just state that I can do that, and if you do not agree with me, you can do the block diagram reduction and make sure that I am correct. And therefore, my ys can be written as k divided by s plus a plus k rs. Now, if I want to find out the response of the system to a step input, okay, so I want to look at the output when I have a step input. Now, what is a step input? A step input is when you have rs equal to a over s, where a is the amplitude of the step, and 1 over s is gives you the step response. So then what is going to be ys? So ys becomes a k divided by s times s plus a plus k. Now this is my Laplace, this is my output in the Laplace domain. What I want to do is I want to calculate my output in the time domain. So what I want to do is I want to calculate y of t, right? So how do I get y of t? So let me just draw a line so that I can distinguish. So to get y of t, what I'm going to do is I'm going to take the inverse Laplace transform. So Laplace inverse of y of s. Okay, and from your Laplace transform equations, um, you would remember that the way you take a Laplace transform is by first of all dividing this equation into partial fractions. So what I want to do is I want to write y of s in the form of, so if you take a look at the denominator here, there are two distinct parts to the denominator of y of s. One is s and another is s plus a plus k. So I want these two denominators to separate out. Okay, so what I do is I want to write this as p over s plus q over s plus a plus k. So that is the form that I want my output to take. Sorry, my ys to take. So if I reduce this, what do I get? I get p s plus a plus k plus qs over s s plus a plus k. And this I can write as p plus qs plus p a plus k over s s plus a plus k. Now if I compare the numerator here, which also is the numerator of ys, and the numerator here, which again is the numerator of ys, I can equate coefficients. And what I can do is I can write p plus q equal to a, sorry, equal to 0, and p a plus k equal to a k. Now this gives me p equal to AK, sorry, this is K, A plus K, and I get Q equal to minus AK over A plus K. And uh, so I know the values of P and Q here in this equation, right? Now, if I know the values of P and Q, I can get Y of t. How do I get Y of t? I basically look up the inverse Laplace transform tables. So if you look at the inverse Laplace transform tables, you would see that the inverse Laplace transform of 1 over s is simply 1, and the inverse Laplace transform of q of a term 1 over s plus a plus k is an exponential term that I'll just write out. So your y of t is going to be 1. So one, it's actually going to be p because you have p multiplied here. So p plus q e to the power minus t over a plus k. So that is going to be your Laplace transform. In the next video, what we'll look at is we'll give values to P and Q, and we'll look at the shape of this output for the step response.